afternoon, everyone. Welcome. Thanks for coming along. I will wait for the last few stragglers to get seated before we get started. Just want to thank the sponsors of today for making this event possible, without which we wouldn't be here. And hopefully you've all filled in your sponsor bingo and got that submitted. Maybe hopefully not, because then that gives me better odds of winning. I don't know. Come on in, take a seat. All right, we're just going to briefly introduce ourselves before getting right into it. I'll start with James.
All right. Hey, everyone. So I'm James number one for the purposes of this talk. So I work at Bankwest in the identity platform. That's what our office in Perth looks like, if you haven't seen it. So back in 2019, a friend of mine convinced me to join his team participating in WACTF, which used to be a Perth-based cybersecurity competition. It doesn't exist anymore. Our team arrived late, and so instead of being allowed in the room with all the other competitors, we were relegated to the foyer outside. In spite of that, we did take fourth place that year. So that event kind of, I guess, inspired me to take an interest in cybersecurity, and so that's kind of my origin story.
Hey everyone, I'm James number two for the purposes of this talk, the slightly cooler James. My interest in cybersecurity also started when I was working at Bankwest. I spent 6 months working in the Security Operations Center there. The team were super passionate about security, just really invested, and I guess some of that passion ended up rubbing off on me. From there, I went on to do some cybersecurity in my spare time, like Hack the Box, WACTF, much the same as James, and that eventually led to me moving from a software engineer position to a security engineer position where I am now. We met when we were both working at Bankwest, probably self-evident by our intros. We spent 6 months working together in the same team and have kept in touch ever since. That was back in 2019 we worked together. And we like to do gymnastics in our spare time together, which has been good fun. All right, so the goals of the session. We've got a few goals that we'd like, hopefully, all of you to come away with at least ticking some of these off. We'd like to give you all a bit of a peek at what breaking in looks like, what attacking a vulnerable service looks like. I know certainly when I was working as a software engineer, this was rarely something I was necessarily exposed to outside of maybe a little bit of mandatory security training, but rarely did I get a chance to actually see what it actually looked like for an attacker to try and break into a vulnerable service. So we'll try and give you a bit of a peek at that. We'll try and share some practical tips. So we do have a live vulnerable website here that we'll be attacking, and hopefully anything that you end up working on won't be vulnerable in at least exactly the same way. I'm sure there will be vulnerabilities, there always are, but hopefully not in the exact same way as this one. We'd like you all to participate in this. This is a choose your own adventure, so more on how that's going to work in a moment, but we'd like you all to get involved and participate in that aspect of the session, which will hopefully lead to number 4, which is inspiring, hopefully, some of you to potentially take this up as a hobby or something that you might end up working in the future. For me, this was something that started as a hobby and eventually led to a change in career for me. And I think it's a really interesting, fun area to work in, so hopefully you can get exposed to some of that as well. So how is choosing the adventure going to work? We're going to start off with giving you a little bit of context, because you're not going to be able to make a decision without some context. And then we'll present to you a few options. You'll see a screen that looks much like this one, but with an actual QR code. And you'll be taken to a straw poll where you'll be able to choose which attack path we want to take. We'll also read out this code, 6-digit code. You can do one or the other. Either go to strawpoll.live and be ready to enter a 6-digit code, or just have your camera app ready to scan a QR code. All right, so on to the live demo portion of this. James is going to narrate while I start exploring the actual website.
Okay, so the vulnerable website that we're going to be pen testing is an online pen store. So here on the home page, you can see there's a catalog of pens, and you can browse through them and add them to cart. There's also a search feature up here, so you can just type a query into the search bar, and it'll filter the list to matching pens. Coming over to here, there's a gallery which shows you some pictures of beautiful pens. Not much to it at the moment, but work in progress, I guess. There's a login page, so this website obviously has an account system. Test credentials are not working, so we're going to register a new user. James is just entering test into every field. There's no validation errors coming up in the password field, so there's no password policy. And now that we've logged in, up in the top right, we can see we have a new option, which is to view our profile data and apparently to edit some of our features, first name, last name, and email address. So looking in the URL is the next thing that catches our eye. We can see that this is hosted in S3, so that means it's a client-side static site. So all of this behavior is implemented through JavaScript, which means we can look through the JavaScript in the DevTools to see what's going on. So the first thing we're going to do is look at this and see if we can enumerate the routes and find one that we haven't seen yet. So we're just going to search through this for routes that we have seen, and immediately we find a list. And so one that catches our eye here is add product. We haven't seen that one yet, so we'll just navigate to that and see what comes up. So we get a forbidden error. So that tells us there's some role-based access control probably going on here. So next order of business would be to try to enumerate the roles and figure out where we stand. So James is just searching for user, guest, admin, strings that appear as role names. And this looks like a map of roles. We only see two, admin and user. So I think it's a fair guess that we're just a basic user and we'd have to be an admin to access this. But we're just going to try to find the session data in browser storage, because that's where spas tend to keep it, and see if there's anything there. And there is, in fact, a role field, and it says user. So that's pretty much confirmed for us. All right, so that gives us our first goal, which is to become the website admin. So now let's look at some of the options that are available for us to do that. Number one, SQL injection. So this one's pretty classic. I'm sure everyone here has heard of it. Taking the search field as an example, if our products are stored in a SQL table and that works by querying it, we can imagine that perhaps our query is going into, our search is going into a SQL query like this. If it's vulnerable to SQL injection, what we would hope to do is to insert some delimiters into that would be able to help us escape the context and pull back some data that was never intended. More on that if we choose that option. Option two is mass assignment. So we know that there's some kind of admin user, and we know that we can register a basic user. So the question here is there a way to upgrade our basic user to an admin? So it's a pretty fair assumption that there's probably a role column in the user table, and that stores the role that is assigned to us. If there's any way that we can update our user record, we may be able to forcibly provide extra input if they haven't protected against it, and overwrite that role field, thereby becoming an admin. Again, more on that if that's the chosen option. Option three is pretty simple, brute forcing. So if we just spam enough login attempts with different passwords, we might luck out and eventually find valid credentials. All right, so now it's time to choose. If you're having trouble scanning that QR code, you can go to strawpoll.live in your browser and type in 602156 as the PIN. We're not going to wait for everyone to vote. We're just going to wait until we have a clear winner in the interests of time.
Seems pretty clear. We've got a favorite.
All right, so mass assignment has it. So that's the path that we're going to go down. All right, so to start this out, James is just going to go to the edit profile page and turn on Burp Suite. So Burp Suite is a tool that proxies browser traffic. So normally when this makes a call to its backend API, that traffic will go directly from the browser. We're going to insert Burp in the middle as a proxy, which will allow us to inspect and modify requests, just tamper with them and make our workflow a bit easier. So we're interested in the update profile page because that's a page that allows us to edit our user record. So James has just sent an update request, and now we can see it here. It's been intercepted by Burp. So if he's just going to send that to Repeater, which is a tool that allows us to replay requests and edit them as we see fit. So we can see here that in the request that he sent, the only fields that were provided were the ones that the form contained, so email, first name, and last name. But the response has given back the complete user record, which includes the role field and says that our role is user. So we're interested to see if we can just add that to our request payload and overwrite what's stored. We've got a successful response, and it does say role admin, so that's a good sign. So James is just going to log out because it probably wasn't intended for us to modify our role mid-session. So logging back out and back in to clean the slate. And we have a whole new menu here. So it looks like we are indeed the admin. And among those pages that we have is the add product page. So we've succeeded in our first goal. We're in.
Had to include it.
Okay, so now let's reflect on what we just did and what the developer got right and wrong. So we managed to use mass assignment because the developer didn't protect against it. Or am I supposed to talk about the technical specifics? Okay, yeah, so basically what we did here was this thing relied on us sending a specific payload, and it just kind of superimposed that over the existing user record and then stored that back in the database. But it didn't do any validation to check the payload that was sent, only included the details that were supposed to be updated. And in dynamic languages in particular, like JavaScript and Python, those objects can generally be anything because they're not statically typed. So what they should have done is to allow list the user input that was allowed, email, first name, and last name, and either discarded any extra data or caused the request to fail if it was provided. And another option would have been to just not use local accounts and use a third-party service like Auth0 or Azure AD or something, because with user account management, the stakes are very high and it can be very easy to get it wrong. Also, a couple of popular JavaScript frameworks are vulnerable to this out of the box. So Nest.js and Fastify in particular, if you're using either of those, they will not do any validation when they bind like request payloads to objects. So yeah, be aware of that if you are using either of those.
All right, James is going to hop on the keyboard and I'm going to be your narrator for the next part.
Am I supposed to do slides first or just?
No, just go to the site, yeah. Yeah, so now that we're admin, James is going to explore around the site a little bit and see what new powers we've got with our admin access. So we've already had a bit of a look at this. We've got this new menu. We can see some server logs. It looks like it's not really properly implemented yet. We've got some notes, some developer notes. They've left themselves a bit of a to-do list, mentioning the use of eval for parsing and it being risky. We'll take a look at that soon. Okay, some to-do note about the log files instead of avoiding using query parameters. Stop using the API host as jump box. Basically a laundry list of things that they've left for themselves to do. We've got the add product page, which we looked at earlier, and an add to gallery page. So we've got a few new options available to us. Nothing too crazy, but the keen-eyed amongst you might have seen some things that we can maybe make use of. So we need to go deeper. Just being the website admin hasn't given us anything too exciting. So our next goal is to get onto getting onto the actual host machine. So how are we going to do that? We've got a couple of different options. Number one is information disclosure. So for this one in particular, we're looking at the server logs page. It, at the moment, doesn't show us anything particularly useful other than a sample log file. But we'll try and see if information disclosure might allow us to gain some information about the host that will then allow us to get onto the actual box running the application. Option number 2 is remote code execution. This one's a pretty significant one to have on your app if it does come up. Probably the most recent huge one would have been Log4Shell, but there's been more recent ones like Avanti and stuff. But essentially what this is, there's various ways that this can happen, but essentially we're going to be providing some sort of malicious payload to the server and get it to run arbitrary code which will allow us to take full control over it. So a classic one would be something like deserialization, where you provide some sort of input, and then when it tries to read that, you take advantage of a bug in the code to basically get it to fall over and get in. For this option, we're going to be taking advantage of the add product to database page. The developer did mention that the use of eval for parsing is risky, so we're going to go right ahead and take advantage of that risk if that's the option that we choose. So we'll leave it to you to choose which option we want to go with. I promise you both options are equally exciting. The last few times we've given this talk, it's always ended up being the same path taken, which is fine if the audience hasn't seen it before. I'll give you a minute to scan the QR.
Does anybody still need the slide?
Otherwise, we'll go across to the results page. All right. No surprises there. We've got remote code execution always sounds more exciting. Everyone always goes for that. That's fine. So we'll be going down that path. All right. So James is now going to demonstrate how we're going to take advantage of this feature for remote code execution. So he's going to the add product page. He's enabled the burp proxy once again, which we've already taken a look at how that works. And he's going to just fill in the form with some dummy data and submit it. Now the submission doesn't work because it's been intercepted by burp, sending that to the repeater so that we now have something that we can repeatedly send and test out different payloads. Oh, no. I've done the options request. I have to redo that one. All right, so we're just forwarding the options request because we're not interested in that one and intercepting the post request. So if we scroll down in that, we can see the data that James entered in the form. And essentially we can manipulate that and submit anything we want now. Now in theory, if the backend application is well engineered, it won't accept anything other than what it's expecting. So James is going to just try and throw some random garbage at it. So start off by sending a string, see how it responds. Okay, we get an internal server error. Nothing too exciting here. Probably pretty much expected. We're going to try and replace our string. So we know eval was mentioned by the developer, which is something that takes a string and turns it into, well, basically runs code that is sent to it as a string. So he's put 1 = 1 there, which would evaluate to true if this was in code. And we get a response back. It says 200 OK, which is probably not correct from the developer. It probably should be an error code. And we get parsed input could not be read correctly, true. So that tells us that that string 1 = 1 was actually evaluated and run as code. So it looks like we've got remote code execution. At this point, we need to determine what language we're working with so that we can actually run useful code to us. So what James is doing here is some JavaScript that will print out the current working directory of the running application. And what we get there is an actual folder path. So it looks like we've got remote code execution and it's JavaScript. Now we're going to fall back on a playbook because running all these commands live would be a nightmare. So what James is doing here is now we know we can run whatever JavaScript we want. So he's going to run a command which is going to use a package manager to install a tool called Netcat. This is going to be useful for us in the following steps. At this point, we don't get any useful feedback from the target. We're basically working blind. We have to assume that this command works correctly and proceed onwards. This is a pretty common theme with these sorts of attacks. Next, we're going to, so we've installed netcat, now we're going to run it. Probably we could have done this in one command, but just for the sake of the demo, we split it up. So at this point, we're now running netcat. We don't get any feedback once again. We just have to assume that it's working correctly on the target. And then finally, we've set things up on the target. Now locally, we're going to connect to the target using netcat on our end. And in theory, we're now connected. So James is just, so we've got a connection here. He's typed in who am I to see what user we are, and ls to see what folders or what files we've got access to in the current context. And he's just going to upgrade our shell to something that's a little bit nicer to work with. And so there we go. We can see we're now root on IP address 10.0.0.10 in this folder. So we've successfully got ourselves onto the actual target machine. So what we set up there is what's called a bind shell. Usually in this space you would hear most often referred to reverse shells. This is the more common approach. Just due to limitations in how I set up this demo, we had to do a bind shell. But the difference is, where in a bind shell, we set up the target to be the listener and we connected to it remotely from the attacker side. Usually, you would set up the attacker to be the listener and the target would be reaching out to the attacker. Just the way networks are generally set up, it's more likely that the target will have access to the broader internet to reach out rather than the broader internet having access to reach in. So that's why reverse shells are more common. But the end result is the same. You end up with a connection between the target and the attacker, where the attacker can run whatever code they want on the target, basically like an SSH connection. So how did we get here? The developer used eval. We all saw the developer had this to-do item about not using eval. They probably knew that it was wrong. But despite the developer knowing that it was wrong, they still ended up in this situation. So how did we get here? They probably thought that the admin is not a malicious user, right? The feature that we took advantage of, which is the add product feature, was locked behind a role-based access control. Only admins could access that feature. So why do I need to worry about a malicious admin when I'm the only admin? So defending against this sort of attack is what's referred to as defense in depth, where assuming that outer layers of your defenses can be breached, you need to still harden inner layers of your defenses to avoid a huge blast radius when something does break into that outer shell. Obviously, if you Google eval JavaScript, the top 5 results are all various pages telling you, do not use eval, it's an awful idea, you should use something more specific to the actual problem you're trying to solve. So that's probably another clue that the developer should have taken on board to not use this. They should have used some actual JSON parsing to parse the input of the form. But it's convenient for the purposes of this demo. All right, I'll now hand back to James, who's going to narrate the final layer of our attack.
All right, so the box that we've got access to is an EC2 instance, which means that we're now on AWS infrastructure. So naturally, our next step is going to be to see what resources in that AWS account we have access to with our role. So a good target to start off with is secret manager. So we're just querying secrets in the account, and it looks like we have the list secrets permission on our role because we've run that CLI command and got back a list of secrets. This one here, super duper top secret, catches our eye as something that we kind of want to have a look at. Now we're going to see if we can actually query the value of that secret. So this is another CLI command to do exactly that. And we get an access denied exception. And then there's a little note there saying that we're not authorized to perform that action on that resource. So we don't have privileges to do it. So next order of business is to see what we do have access to and see if there's any way that we can climb our way up to accessing that. So we've skipped over a little bit because traversing through the IAM hierarchy is a little bit tedious, but the only role policy that's attached to our role is this one. This is the document, and you can see in this statement that we have access to EC2 run instances. IAM create policy version is another one that catches our eye. And down here, IAM pass role is also an interesting one. And in the resource section of that statement, there's a wildcard, so we can perform those actions on any resource. Looking up here, we actually do have get secret value, but it's scoped to resources with these ARN prefixes. That's no use to us at the moment. Right, so now we've got our next goal, and that is to steal secrets. So let's look at the options that are available to do exactly that. Number one, pass role. As the name implies, what this allows us to do is for one entity to pass a role to another. So an example of that is when you're provisioning an EC2 instance, and it may need access to some resources like credentials and secrets manager. You can pass it a role that confers that access, and we can abuse that by provisioning one and just SSHing into that instance and then using those permissions. Option 2 is create policy version. What this allows us to do is to create a new version of an existing IAM policy. So at the moment when we query secrets manager and try to read that secret, it tells us no because we're not allowed. But we can update the policy that's attached to our role to say that we can, and then the next time we try to query it, in theory, we should be able to read it. So your turn to vote. Again, if you're having trouble with the QR code, the pin is 939765 if you're struggling to read that. And same rules apply, we'll just wait for a conclusive result. All right, this one's tight, so maybe, it is swinging a little bit towards create policy version, but maybe we'll just give it another minute and see where it goes. Is anybody still voting?
All right, I think create policy version wins then.
All right, so we're going with create policy version. It's just one out. So now let's do exactly that. So the first thing we need to do is to find the name of a policy that is attached to our role that we can update. We only have one policy attached to our role, so that's the one that we're going to target here. Now, instead of constructing this on the fly, James has just got it in the playbook, but what he's got here, and I'll go through it line by line, is an AWS CLI command to create a new policy version. So as you can see, it's updating policy. It's providing an inline policy document here, and that only has one statement. And what that does is it allows the list secrets and get secret value actions on any resource in the account. And also very important is we've got set as default as a flag here. And what that means is that any role that isn't pinned to a specific version of this policy will be inherited as the default. So when we run it, it succeeds because we have that permission. And it says that it's the default version. So now we're just going to try querying for that secret one more time. And there you go. We've obtained the secret string. So one thing to call out at this point is that we kind of put this in the account as a flag to demonstrate that privilege escalation path, but we essentially had admin privileges there. We could have created a policy document with every single IAM action, put a wildcard resource on it, and we would have been able to basically do anything we wanted within that account. Right, so also worth noting that we did do a little bit of IAM querying by hand here. We did skip a little bit of it in the interest of time. But if you're working blind, if you have access to a resource, but you don't have information. You can use tools like Weird Owl, Paku, or Redbodo to automate that process. Just probe API endpoint, and they can distinguish from the responses whether or not that permission is allowed. Sorry? Like this, holding it to the top. Okay. Sorry about that. Okay. Yeah, so anyway, let's reflect now on what the developer did wrong. So the main thing they should have done here is to apply the principle of least privilege. So two components to that would be, number one, segregating duties. So this API host shouldn't have been provisioning other infrastructure, and it shouldn't have been manipulating IAM policies. Number two, don't put wildcards in your IAM policies. Scope them as narrowly as possible.
All right, and that brings us to the conclusion of the live demo portion of this. So we've gone from visiting a innocent pen store to becoming full admin of their AWS account. So what did we learn? Well, it depends a little bit on the path that we took. We learned about sanitizing and controlling user inputs with regards to the mass assignment. You want to allow list what fields are allowed to be posted to avoid mass assignment. Follow the principle of least privilege. This probably mostly applies to that final layer where the API host was able to escalate its privileges to full AWS admin. Applying defense in depth applies mostly to that second layer where the developer had implemented something a bit dodgy, but they didn't necessarily think it was an issue because it was protected behind role-based access control. So as promised, we're going to share a few resources now about how you can get into exploring this space. This was a relatively simple example for the purposes of a half-hour, 40-minute demo, but these can get really quite in-depth and interesting if you want to explore this space. So Try Hack Me and Hack the Box are some tools you can use for exercises that will behave similarly to this. The slide's going to progress as we go along. You can take a photo at the end if you want, probably most productive. For Hack the Box, specific shout out to IPSec, who offers great tutorials. Whenever a box gets retired from Hack the Box, you can be assured that there's going to be a tutorial from IPSec on YouTube doing a full walkthrough that you can follow along. Pentester Lab and OWASP Juice Shop are things that have been recommended to me, but I haven't used personally. There are also some certs in this domain. I'm sure there's many more than just these two, but these are just the top two that came to mind. OSCP and CEH are both certifications in this domain. If you get into this and you want to take it a step further and actually get certified, these are some options. And like James and I mentioned, capture the flag events are one of the things that got us interested in this domain, and they're really quite fun and interesting. So ctftime.org gives you an overview of a bunch of upcoming CTFs, and I just took a screenshot of some upcoming ones. So these are some upcoming ones happening soon that you can take a look at. Another thank you to the sponsors for making this event possible, and thank you all for coming.
I think we've got time to take some questions.
Any question from the audience side?
If we chose the information disclosure path, what was the general idea that you were going to use to attack the, I assume you were going to get equivalent access to the AWS box, is that right?
Yeah, so all the paths rejoin at each decision point. So it's just different ways to get in. So the information disclosure one would have been, you would have been browsing files locally on the target, and you'd be able to find SSH keys to then get onto the target.
Fantastic, thank you.
Any further questions?
There's one at the back.
Hey, I was just curious, the CTF idea sounded pretty interesting. How exactly, well, maybe not exactly, but how roughly does that work? Does one team set up a box and the other one tries to attack into it, or?
It really depends. Most of the CTFs I've attended have usually been kind of Jeopardy style, or basically a bunch of challenges set up in various ways that the participants can try and break in to basically one exercise at a time, trying to get a flag in various ways. I think like the WA CTF one, we had everything from like hacking a Game Boy game to simple reverse engineering to decryption and things like that, maybe deserialization. I do know there are attack and defend type simulations that do happen, but I don't know if they'd classify strictly as a CTF. I mean, potentially those are a lot more effort to organize, and I haven't personally been involved in any, just heard stories of them, but they do sound really interesting.
I guess the difference is generally with a CTF, each challenge is like focused on one specific vulnerability or technique, whereas something like Hack the Box has a number of layers, kind of like what we've done, and you'd have to take advantage of several different things.
I like to document my bugs as tickets and explain how things happened, then write the fix, test it, then deploy it and stuff. What do I do when someone finds a vulnerability? Like, my ticket's just going to explain how to break into my system.
Well, I mean, if it's reproducible, you usually be able to find the general area that the vulnerability is occurring in. Chances are, whatever vulnerability it is something that has been done 1,000 times before, most of the time, unless it's like a brand new CVE that's been discovered on your system. It's most likely going to be something that if you just Google it, there's going to be a very common way of addressing the problem. Even if you Google the CVE that you're particularly vulnerable to, there's probably going to be guidance around how to resolve that. It's hard to say specifically. It's going to vary on a case-by-case basis depending on what the actual vulnerability is. But a lot of these, as we walked through it, most of the solutions were pretty self-evident. If you get in via mass assignment, you Google mass assignment fix or anything like that, and you'll find out how to fix that.
Yeah, but so between the time of someone finding the problem and me fixing it, do I just not mention anywhere in my public GitHub issues that I have this problem?
Yeah, well, there's different approaches to that. Usually, if there's a vulnerability like that, it would be disclosed privately so that not the whole internet doesn't know about this vulnerability in your service. And then you'll have some time to actually issue a patch. And then once the patch is dropped and your service is no longer vulnerable, then you can share exactly what the issue was. The person who found the vulnerability can publish their blog post where they talk about finding this vulnerability, et cetera, et cetera. So there is a little bit of security through obscurity by not immediately sharing the vulnerability with the wider internet.
So from the flip side, you've mentioned, not from the attacking side, but from the defending side, you've mentioned things like FastFire and Nest.js have inherent flaws in them that leave them open to these kind of attacks. Are there ways that we can, are there places that have recorded documented faults, not necessarily CVEs, but framework issues that we can look at when we're choosing technologies for our stacks?
That's a great question.
So I think with the Nest.js and FastFire examples in particular, that's just kind of the default configuration of those frameworks. So generally, I guess if you're writing code in that way, where you're taking a payload and updating, just superimposing it on top of another JavaScript object and then saving that to a database, you should kind of be aware of what you're doing. But it's just kind of inherent to a certain, pattern of writing software if you're using that without any specific configuration. There are instructions on their websites for how to configure them to do that validation. It just doesn't come out of the box.
Yeah, so for a lot of things like this, you can Google hardening guides. So for most products or services or things like that, wherever you can configure something, there's probably going to be some sort of hardening guide that can tell you exactly what are the things that you should be focusing on when you're trying to configure something like this. So any FastFire or Nest.js hardening guide would be telling you probably to look at that aspect, that configuration, and make sure you've got allow listing set up.
What do you think was the greatest vulnerability in this demo site?
The greatest vulnerability in this demo,
Like the most egregious flaw, the design issue?
I mean, the eval one probably, like it's super dumb, but it made for a very convenient demo for the purposes of this talk. Yeah, I wouldn't call it the greatest one though. It's like the silliest one silliest mistake that a developer could make probably, because I mean, if like I showed, if you Google it, everyone tells you not to do that.
Yeah, I mean, like it's kind of like the Swiss cheese sort of model, right? Like it took several vulnerabilities at different layers to get to the point of being able to like own the AWS account. But also, I think with the eval one thing we didn't demo in the interest of time is, you know, it kind of looked a bit contrived where we just knew to try 1 = 1. Typically what you do is like use a fuzzing tool on the endpoint, which is where you take a list of different payloads like that, and it'll just try them one by one and you know, distinguish when it behaves differently in response.
One issue not explicitly pointed out was the fact that the web server was running as the root user.
Yep, another good one, yeah. So if you do things like hack the box, usually there would be a step after you get onto the target where you'd have to privesc from your user account to a root account before you can then get the flag. So in the interest of time, we skipped that. We could have included something like that where the API was running as a less privileged user and we had to privesc from there before we had access to like the AWS CLI and stuff like that. But not included for the purposes of this demo.
Thank you.
This is great. I don't think we've ever had this many questions, or maybe we've never had this much time for questions.
From your experience in the banking sector, are there some specific vulnerabilities or specific protections you put in place just because it was for a banking site?
It's hard to say specifically to banking. I mean, I do feel like, you know, we talk about big banks moving slowly, and that's why they have the, you know, all their neobanks moving that are much smaller, moving more quickly. The reason the banks move so slowly is because of that security aspect as well as just being big. It's a lot of procedure-based mitigation, risk mitigation, a lot of time spent, you know, pen testing, anything that's going to be external facing, things like that. Yeah, I don't know, nothing super specific. It's just like applying all the protections all the time, which makes things slow, but hopefully a bit more secure. I don't know. I no longer work for Bankwest, so I can't comment as well. Maybe James has.
Yeah, that sounds about right.
So there are so many tools out there, like Kali Linux with all the libraries, etc. But have you looked at tools that use Gen AI, like Copilot or I don't know, ChatGPT? Has any work is being done, like to help you to analyze all the layers and help you design the breaking in? Of course, for good purposes.
No, it's not actually something I've explored. I have seen like some articles around people trying to jailbreak ChatGPT to allow it to produce malicious output and things like that. I think a lot of those chatbot tools do have some amount of protections in place to stop people from, basically stop it from enabling crime immediately out of the box. Obviously, people are going to find ways around those protections or generate their own chatbots that will produce whatever, you know, malicious phishing lures that they want and things like that. But it's not something I've personally messed around with. yeah, if you know of any interesting tools in that space, would love to know about them.
On the flip side, and I'm not shilling for any like particular product here, but I know that there are services that do like static code analysis for vulnerabilities that are implementing AI to kind of improve the heuristics that they have for actually detecting vulnerabilities during the dev process.
Any question?
What kind of challenges do the security team and the development team have when they're trying to integrate with one another for the purposes of security?
Yeah, I mean, a very common one is, security appearing to be a blocker for, new features and things like that. It's a really hard one to solve. I don't think it's one that's completely solved in the industry. I'm sure there's plenty of developers, potentially some in this room, where they feel like they've been blocked by security on releasing something and been knocked back because something needs pen testing or something like that. There's a general trend of trying to move left as much as possible with security, consulting with the developers as early as possible so that you don't end up with a massive spanner in the works right at the last second, something needing to be completely refactored or changed because there's some inherent flaw in the design that makes it insecure. So probably the biggest way that we can assist with that sort of integration between devs and security is just being as open as possible, talking to each other as early as possible in the development process so that issues get highlighted when we're not past the point of decisions being made. Yeah. I don't know, anything to add, James?
Yeah, no, I agree with that. I think probably the most common thing I see is when developers want to loosen particular controls that they don't think apply to things like WAF and that kind of thing. And then that creates tension. And I think that's just a symptom of the lack of early engagement and the siloing between the teams. Because if people don't kind of fully understand, I guess, the scope of the security controls on the dev side or the actual circumstances of the app on the security side, then naturally it's going to be hard to collaborate properly and like find fit for purpose solutions that aren't actually going to just become a blocker for people.
Yeah, it's really important for the security team to present as friends, as approachable, people that you can talk to. They need to be going out to, team engineers, social events and things like that, being a friend of the developer and not just some like hooded figure that sits in the back and only comes out when you're about to release a feature or something like that and spooks you. Yeah.
Okay, all right. Yeah, let's thank James and James for the wonderful technical talk again.
Thank you, everyone.